All right, so we've been talking about normal distributions and density curves. What is the area of any density curve? 1. The area of any density curve is 1. And if it's a uniform density curve, it just looks like a rectangle, and you just use area equals base times height to find those sections. So today we're going to learn about the empirical rule, which is going to help us find sections of a normal distribution, which is a bell curve. All right, so why are normal distributions so important, first of all? So the biggest 3 reasons are that normal distributions are good descriptions for some distributions of real data. Normal distributions are good descriptions for some distributions of real life data, which is what we want to analyze. Distributions that are often close to normal will include scores taken on an ACT or an SAT test, an IQ test, careful measurements of the same quantity, like if we were looking at the diameter of like a tennis ball or something. Most of them will have the same value, but then some of them will be slightly bigger or slightly less than. Characteristics of biological populations like lengths of crickets or yields of corn, which I know you guys are super into counting yields of corn, like you do that on the weekends, so you might want to use this, right? Normal distributions are good approximations to the results of many kinds of chance outcomes. So things like flipping a coin and counting how many heads we might get. Normal distributions are going to be really good approximations for those types of chance outcomes. And then finally, many of the inference methods in chapters 8 through 11, which we will get to after Christmas, are going to be based on normal distributions. So normal distributions, very important. We're going to use them a lot this year. They will keep coming back all the time. So you're never going to get rid of them. Cool? Yes, Miss Lakey, that's cool. All right. So remember last week when we were taking notes, we talked about this distribution of the Iowa Test of Basic Skills, the ITBS test. It is a vocabulary scores for 7th grade students in Gary, Indiana. It is approximately normal with a mean of 6.84 and a standard deviation of 1.55. All right, so we might want to ask ourselves something like this. How unusual is it for a Gary, Indiana 7th grader to get an ITBS vocabulary score of less than 3.74? So let's say this is our distribution. It's a normal distribution. Well, it's a density curve. So what's the area underneath that curve? 1. So I know the area underneath this curve is 1 because it is a density curve. All normal distributions are density curves. But I want to know what is the area of that little section from 3.74 down. And so it might be a little difficult to find it because I don't know base times height. But I do know that the boundary of that 3.74 is exactly 2 standard deviations below the mean. So when I look at this value, I can see that it is exactly 2 standard deviations below the mean. So when I take 6.84 and I subtract 1.55, I get 5.29. And I subtract 1.55 again, I get 3.74. So that's exactly 2 standard deviations below the mean. That's going to be very helpful. So the empirical rule. Calculating the shaded area isn't as easy as multiplying base times height like we did with density curves. So calculating the shaded region is not as difficult or is not as easy as multiplying base times height like we did with the density curves, but it's actually not that hard if they are on exact standard deviations. And so this is a value that is exactly on a standard deviation, so we're going to use something called the empirical rule. So here's the empirical rule. in any normal distribution that has a mean and a standard deviation, about 68% of the values in that distribution are within one standard deviation of the mean. So if I go from the mean and I go up one standard deviation and down one standard deviation, I have captured 68% of the data. That's over half. That's the majority of the data. 95% of the values are within 2 standard deviations of the mean. And 99.7% of all the data in that distribution is within 3 standard deviations of the mean.
I'm sorry to interrupt your class. Were these two doing something for you?
No, they were not.
Okay. I've just interrupted a classroom. That is unacceptable. I apologize.
That's okay. All right. So 68% of the values fall within 1 standard deviation of the mean. 95% of the values fall within 2 standard deviations of the mean. And 99.7% of values fall within 3 standard deviations of the mean. So that's our empirical rule. Although there are many normal distributions, they all have properties in common. In particular, all normal distributions are going to follow the empirical rule. The empirical rule means that it is learned from experience or by observation. All right, so some people are going to refer to the empirical rule as the 68, 95, 99.7 rule. This is really, really helpful because if I remember this rule by using the actual numbers, then I know what the values are. It's 68, 95, 99.7. 1 standard deviation, 2 standard deviations, 3 standard deviations. So by remembering these 3 numbers, you can quickly estimate the proportion or the percent of observations in a specified interval in a normal distribution. So by remembering these 3 numbers, 68, 95, 99.7. So, what percent of the data is within 1 standard deviation of the mean? 68. What percent of the data is within 2 standard deviations of the mean? 95. And what percent of the data is within 3 standard deviations of the mean? 99.7. Perfect. 68, 95, 99.7. All right, cool. Furthermore, we can break down the sections of the normal distribution into these smaller sections. So, if 68% of the data is within 1 standard deviation, and these are symmetric sections, then if I take 68% and divide by 2, then that means each of these sections on either side of 0 are going to have 34% of the data. Okay, I just took 68% and divided by 2. 68% divided by 2, so from 0 to -1, that is 34% of the data. And from 0 to +1, that's 34% of the data. Okay? Now, is there a way that I can get this section here from -1 to -2 or from +1 to +2? Any way you guys think about I could get those sections? So, what percent of the data is within 2 standard deviations? 95. I've already labeled the middle 68%. So if I take 95 and I subtract that middle 68, then I will have the total that would be in each of these, or total in both of these. And so I could then divide by 2, and that would give me each section. So 65% minus the 60, that says 95. That's not a 6, that's a 9. 95% minus the 68 that's in the middle divided by 2 gives me 13.5 and 13.5. So that's what percent of the data is within, is from 1 to 2 standard deviations from the mean on both sides. 13.5 and 13.5. All right, Same thing. Take 99.7, because that's 3 standard deviations, and subtract 95, because we've already labeled that middle 95 that's within 2 standard deviations. Divide by 2, and I get 2.35%. Have we labeled the entire distribution? Not quite. There's the part that's in the little tails. So these tails, from -3 out to negative infinity, or from +3 out to positive infinity, those have a little bit of section, or a little bit of area in them. So 99.7% of the graph is shaded. What's left? 0.3. And so I have a section over here and a section over here. So what percent is in each tail?
1.5.
Perfect. Half of the remaining 0.3 is 0.15, and that's what's in each tail. So that's the 68, 95, 99.7 rule broken down by little bitty sections. Okay? So the good news, guys, every normal distribution will have these same percentages every time. So you don't ever have to do this ever again if you remember the numbers. So it will always be 0.15% in the tail, 2.35 for this little section, 13.5% here, 34% here, 34%, 13.5, 2.35, and 0.15. That will never change in any normal distribution that you work with. Cool? Any questions how we got any of those numbers? We're just doing subtraction and division here. All right, so what's the point? Who freaking cares, right? So why do I care about these sections? Now that we know what each section is, what percent of the data it is, now we can do some calculations. So that's what we're going to do next. So the distribution of Iowa Test of Basic Skills vocabulary scores for 7th grade students in Gary, Indiana can be modeled by a normal distribution with a mean of 6.84 and a standard deviation of 1.55. We've already seen that. We're going to use the empirical rule to answer some questions. So the first question, what percent of these students have ITBS vocabulary scores that are less than 3.74? So this was our main question. So step 1, we would want to sketch the normal curve and label our values. So we would want to sketch our normal curve and label our values that are 1, 2, and 3 standard deviations from the mean in each direction. So you can go ahead and sketch your normal curve, label those values that are 1, 2, and 3 standard deviations from the mean. Yes, ma'am?
Where did the values on the x-axis come from?
Yep, so whenever I take the mean of 6.84, that goes for the middle here, that's the mean, and then I do my 1, 2, and 3 standard deviations in either direction, then I would add 1 standard deviation, so 1.55, and I would get 8.39. And then I would add another standard deviation, and that would give me 9.94. I would add a third standard deviation, and that would give me 11.49. To go the other way, I would be subtracting 1.55 each time. So 6.84 minus 1.55 gives me 5.29. And then subtract again, and again, and again. So there's our first step. We're going to sketch and label our mean and 3 standard deviations. Now, why is it 3 standard deviations? Why do I go 3? Why not 2? Why not 5? So once I get to 3 standard deviations, I've got 99.7% of the data. So that's almost all of it. It's a pretty good amount. So that's why we like 3. So everybody have it sketched? Your next step is going to be to shade the area of interest. So we're looking at ITBS vocabulary scores of 3.75 or less. So you just basically, and you can even draw a line if you want. You can draw, if you don't have lines. These lines you can draw all the time. I just didn't draw them on the picture. So you're basically shading this area right here. And then all you got to do is add up those areas. Okay? So what is the percent of this tail? From 2.19 to infinity, negative infinity? That's 0.15. So that's that. And then that second section is 2.35. So I just basically add those two sections together. And that will give me the answer, which is 2.5%. Now you can also find this by subtracting out all those other areas, but that's a whole lot of areas. But basically, we're just adding up those little sections that are shaded. Any questions on that? Okay, let's do another problem. This one, what proportion of Gary, Indiana 7th graders have ITBS vocabulary scores between 5.29 and 9.94? So it's the same distribution with the same X values. Same distribution, same X values. You guys are going to get so tired of drawing a normal distribution. Trust me. It's the same distribution of ITBS scores and the same X values. And now we're looking for the values that are from 5.29 to 9.94. We're looking for those values. And all we got to do is add up the areas of interest. So what percent of the data is from 5.29 to 6.84? What percent is there? Let me put the lines there. These lines will be helpful. What percent of the data is right there? From 5.29 to 6.84 right here? So that 13.5 is this one. This one's 34. Yep. So this is from 0 to 1, negative 1 standard deviation. So this is going to be 34. And then what is it from 6.84 to 8.39? Also 34. And then what is it from 8.39 to 9.94? That's 13 and a half. So I just add up each of those areas. So I've got the two 34s, and then I've got the 13 and a half, and so my answer is 81.5%. I'm just adding up the sections. Same thing on this. You can also take 100% and subtract out the little sections that we did not use. You can do that as well. So again, normal distributions, they're bell-shaped. Can't use base times height, so I have to use something like this. This is the empirical rule. All right. Note that the empirical rule applies only to normal distributions. The empirical rule applies only to normal distributions. If you have a uniform distribution, like a box, don't try to use the empirical rule. It's not going to work. Your percentages won't be the same. So empirical rule only applies to normal distributions. If you have a skewed distribution, this won't work. Got to use something different. All right, now we're going to do something a little different. We're going to go backwards now. So we're going to actually look at how the empirical rule and percentiles go together. So you can use the empirical rule in reverse to estimate a value that corresponds to a certain percentile. Well, first of all, do you guys remember what a percentile is? What's a percentile?
The percentage of values
Very good. So a percentile is a value that has a certain percent underneath it or less than it. Okay? A percentile is the percent of data in a distribution that is less than a particular value. So that means your percentiles are always coming from the bottom or the left side of the normal distribution. Okay? You'll see what I mean as we do some examples. Stop the car. Many studies in automobile safety suggest that when automobile drivers must make emergency stops, the stopping distances can be modeled by a normal distribution. Suppose that one model of car traveling at 60 miles per hour under typical conditions on dry pavement. The distribution of stopping distances are approximately normal with a mean of 165 and a standard deviation of 4 feet. What stopping distance is at the 84th percentile? Okay. Again, we are going to draw your distribution. Kind of seems like we just get to draw normal distributions all day. We're going to draw our distribution. We are going to label our mean and our values that are 1, 2, and 3 standard deviations from our mean. All right, how did I get these numbers? 165 is the mean, and then I'm just adding 4 feet. I'm adding 4 feet, I'm adding 4 feet, I'm adding 4 feet. I do that 3 times. And then I'm subtracting 4 feet, subtracting 4 feet, subtracting 4 feet, and I do that 3 times. And so that's how I got those numbers. Woo, I'm sorry, my bad. Let me go back. There you go. So sorry. So that's how we get the numbers. Everybody feel okay about that? Okay. Now, I want to find the value that cuts off the 84th percentile. So that means that there's some value here that has 84% of the graph below it. Okay? There's some value that has 84% of the graph below it. So basically, I'm going to start on the left, and I'm just going to start adding up sections. So I'm going to start with, until we get to the 84th percent. That should say 84%. I'll have to fix that. So 0.15, because I'm trying to get to the 84th percentile. 0.15, yes?
Where did you get 151?
Because I can't add or subtract. What should that be? What should that be? That should be 153. Thank you. That's 153. I'll fix that. Cool. I'm just your math teacher, you guys. I don't really add or subtract well. All right, cool. So this should also say the 84th percent mark. Apparently I should have been more, whatever. Anyways, I'm going to keep adding. So when I add these first 2 sections, have I gotten to the 84th percent mark yet? No, when I add those 2 sections, I'm only at the 2.5%, right? So 0.15 plus 2.35, I haven't gotten to 84% yet, so I'm going to keep going. I'm going to take 2.5 and I'm going to add the next section, 13.5. I'm at 16%. Have I gotten to 84 yet? Nope, I'm going to keep going. I'm going to add the next section, which is going to be 34%. I would be at 50% at that point, right? So the middle is 50%. And then I'm not there yet, so I'm going to go again. 34%. Now I'm at 84%. Once I get to that 169, I am at the 84th percentile. So what is the 84th percentile? It's 169 miles per hour. Because from 169 down, there's 84% of the data. Does that make sense? Okay, let's do it again. We're going to practice this again. Yes, ma'am.
Do you have to label the graph when we're doing this on like a test or a quiz?
You don't have to necessarily label everything. You just have to label, or you have to like show your boundaries. So show your lower boundary and your upper boundary. All right, so let's talk about cereal. Here is the numerical summary of data on calories per serving in 77 brands of breakfast cereal. The distribution is approximately normal. How many calories would a box have if it is at the top 2.5% of all cereals in the distribution? Well, how are we supposed to do that if it's at the top? Well, we'll start at the top. So look, we have 77 cereal boxes. We have a mean of 106.883. We have a standard deviation of 19.484. And then we have all this other data. None of this is going to matter for us for this problem. We're just extra. We're going to draw the distribution. Are you guys loving drawing this distribution yet? Isn't it fun? What's your mean? 106.883. Do you know how to get the standard deviations? Yeah, you add and then subtract. So there's all your numbers. So we're going to label our mean and our standard deviations. Super fun. All right, and then we are trying to find what value, how many calories does a box have if it is at the top 2.5%? I thought you said top. I was like, yeah, top. The top 2.5%. So we're going to start at the top. Oh, well, I labeled all the percentages on this one. But the top 2.5%, so where's it at? What is the cereal box calories that are at the top 2.5%? Yep. Perfect. 145.851. Any questions? Isn't this easy? For now. It's not that bad. Let's try this last practice problem here. We've got double stuffed Oreo. Statistics students Ryan and Allie collected data on the weight of cream in grams in a random sample of 45 double stuffed Oreo cookies as part of their final project. The summary statistics for the data are shown here. So we've got 45 of these double stuffed Oreos. We've got a mean of 6.742 and a standard deviation of 0.184, and then all that other junk as well. We want to find the weight of a double stuffed Oreo that is at the 16th percentile. We're going to draw the distribution. We're going to label the values for the mean and 1, 2, and 3 standard deviations for the mean. Are you getting any better at drawing your normal distribution yet? No, it's still bad? Man. So all we did, I'm taking the mean of 6.742 and I'm adding 0.184 and subtracting 0.184. That's all I did. No big deal. All right, we are looking for the 16th percentile. So, if I start at the bottom, trying to find the 16% mark. So So the first little section is 0.15%. Have I gotten there yet? Nope. I'm going to add the next section, 2.35. I'm at a total of 2.5%.
Not yet.
I'm not there yet. Do I keep going?
Yeah.
All right. I'm going to add 16%. Where am I at?
They're at 16.
I'm at 16%. Sorry, I'm adding 13.5. I'm at 16%. So what is the 16th percentile?
6.558.
Let's freaking go. The answer to the question is the 16th percentile is a weight of 6.558 grams.
Oh, I read it wrong.
Isn't this exciting? All right, guess what we're going to do now? We're going to find the top 16th percentile. So guess what we do? We do the same thing. We draw a distribution. Y'all can use the same distribution. Fine. All right, the top 16%. So here we go. Have I gotten there? No, I'm not there yet. I'm not there yet, Tori. I just have the little tail over there, the little baby tail. 0.151%. I gotta keep going. Am I there yet? No, it's like on vacation. Are we there yet? Are we there yet? Are we there yet? Guess what? I'm there. Whee! What is the top 16th percentile value for this distribution? 6.926. Who's loving life right now? Heck yeah. This is the easiest thing you've done your whole life, isn't it?
Just not the drawing.
You hate drawing? I hate drawing too. It makes you, it's aggravating, I know. I know. Oh my God. Wow, those are very good. Dang, girl. All right, your favorite distribution right here. You ready? The amount of time that statistics students spend on sapling learning at home follows a normal distribution with a mean of 15.825 minutes. That's about it. Actually, that might be a little bit of an overestimation. And a standard deviation of 1.217 minutes. We're going to sketch and label the mean and the values that are 1, 2, and 3 standard deviations of the mean. We're going to find the proportion of the data that's between that and that. We're going to find the percent of students and blah, blah, blah. You're going to answer all these questions. Are you ready? Go! So let's look at this example here from yesterday to see if we can remember what we did. So the amount of time that statistics students spend on sapling learning at home follows a normal distribution with a mean of 15.825 minutes and a standard deviation of 1.217 minutes. And we have all the data there. And we're supposed to sketch and label the mean and the values that are 1, 2, and 3 standard deviations from the mean. So that's the first thing we're supposed to do. So let's see if you did this. So you made a distribution, yes? Woohoo! And you labeled the mean of 15.825, and then 1, 2, and 3. So what is the value for a student that spends more than one, or at 1 standard deviation above average? What is their value? 17.042. All I did was add 1 standard deviation. What about 2 standard deviations above? 18.259, and then 3 standard deviations above? 19.476. And then if I go the other way, what about 1 standard deviation below? 14.68. 608. 608. Okay, 2 standard deviations below? 13.391. And 3 standard deviations below? 12.174. Okay, cool. All right, did everybody get that? All right. I want to, before we move on to actually answering the questions, see if you guys remember the percentages. What percentages are these 2 sections in the middle? Each of them. How much is each of them? 34 and 34. So this is 34%. This is 34%. Perfect. This is going to just make answering the questions way easy. All right. What are the next 2 sections from the middle? 13.5 and 13.5. Cool deal is that will never change in a normal distribution. And then what about this little section here? 2.35 on each side. 2.35%. and 2.35%. And then what about in the tail? 0.15%. Okay, so that's a very small amount, 0.15%. Okay, so those are the percentages. Should make answering this question super easy. Okay, all right, so number two. I'm going to leave it on this screen so we can see it. Number 2 says, what proportion of the data is between 13.91 and 17.042? What proportion of the data is between that? So basically, I'm just adding up those 3 sections. What did you guys get? This is number 2. What did you guys get for number 2? 81.5%. FYI, a proportion is a decimal. So it's just take the percent, turn it into a decimal. So it would be 0.185 or 0.815. Blah. Cool on number 2? All right, let's look at number 3. What percent of students are on Sapling at home between 14.608 and 19.476? All right, so add those sections up, and what percent did you guys get? All right, so we got 34 and 34 is 68, plus 13 and a half, that would be 81.5, plus 2.35, that is, what did you say? 8.85. Very good, very good. Perfect. All right, now we're looking at number 4. Number 4 says, what proportion of students spend more than 18.259? So we're adding up these 2 sections. What proportion is that? That would be 0.025. 0.025. Proportion, again, just means a decimal of the percent. So it is 2.5%, but that is 0.025 as a proportion. Perfect. All right, number 5. There was actually a typo on number 5. Did I tell y'all about that yesterday? There's a typo on number 5. So on number 5, it actually should ask you to find the 99.85th percentile. So it's not the 99.75 or 0.7 because you can't find that yet, but 99.85. So if we start adding up our percentages, so if I start on the far left, I'm at 0.15. Now I'm at 2.5. This would be the 2.5 percentile because there's 2.5% below it. If I keep going, this mark, 1 standard deviation below average, that's the 16th percentile because there's 16% below it. If I keep going, I'm at the middle. What is the percentile now? The 50th percentile. Very good. I keep going. Now we're at the 84th percentile. This value, 1 standard deviation above average, will always be the 84th percentile. Keep going. I am now at the, what is that? 84 plus 13 and a half? 97.5. I'm at 97.5. That's the 97.5 percentile. And if I add one more, there I am. We are now at the 99.85 percentile. So what is the value that is at the 99.85 percentile? 19.476. 19.476. Cool? All right. Last question here. How long is a student spending on Sapling Learning if they are in the top 16 percentile? So again, now we're starting at the top. There's 0.15. Here's the 2.5 in the top. And now we're at 16. So the answer would be 17.042 minutes. Cool? How do we feel about that? Perfect. All right, so here's what we're going to do today. Today we're going to deal with what if it is not on the exact standard deviations. So what if I wanted to know the proportion of students that spend like 15 minutes or longer? right? So that's not on an exact standard deviation. So what do I do? That's what we're going to talk about today.